Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
GITAI Robotics is a space robotics startup that aims to provide safe and affordable labor in space and reduce operational costs by 2 orders of magnitude. They're developing highly capable, safe, and reliable robots to help build and maintain satellites, space stations, lunar bases, and cities on Mars. My guest is Sho Nakanose, CEO of GITAI Robotics. Sho, welcome to the program.
Thank you for having me. Very nice to meet you.
It's my pleasure. Let's start from the beginning and find out what inspired you to start GITAI Robotics and what is your vision for the company?
Originally, I have loved science fiction since I was a child. So I have started to develop prototype of sci-fi-like robots. And it turns out our startup and GITAI product. So yeah, originally that was my just individual project and it turned out startup 7 years ago. And our vision is to provide robotic workforce to build infrastructures such as solar panels, communication antennas, habitation modules, and even ISAM plants on the Moon and Mars, minimizing the cost of working in space by 100 times.
So what are your primary products and services that GITAI Robotics offers, and how do they help reduce operational costs in space?
We have 2 products. One is robotic satellite equipped with robotic arm, capable of conducting rendezvous, docking, maintenance, inspection, and life extension operation for the target satellite in low Earth orbit or GEO. And the other is lunar robotic rover equipped with robotic arm and tool changer function, capable of moving around on the Moon and conduct various operations such as maintenance, inspection, repairing, even assembling solar panels or communication antennas on the Moon.
How then is that robotic, the lunar rover, the R1.5, how does that differ from other lunar rovers that we're seeing under development?
I think we have 3 different points. One is autonomy. So our lunar robotic rover equipped with robotic arm is highly automated so that capable of conducting various operations autonomously. And the other is a tool changer function. So our robotic arm has a tool changer function so that our robotic hand is interchangeable, such as from like backhoe, shovel, and effector to robotic hand. And also our robotic arm is not fixed robotic arm. Through dedicated interfaces, our robotic arm can walk around horizontally and vertically like an inch arm. So these 3 points are makes our lunar rover and robotic arm stand out and competitive.
Now, your company also recently launched an autonomous robotic arm to the International Space Station. So what concepts are you hoping to prove with that effort?
Yes, we're really glad to launch our robots to the space station. And actually, so this is our external demonstration will be mounted on the outside of the space station, but the operation we are going to conduct are operation required for on-orbit satellite servicing, such as maintenance, inspection, or tool changer function, and even life extension operation as a attachment has a hardware module on the target satellite. So we are going to conduct that kind of on-orbit satellite servicing operations outside of the space station.
When you say that the robotic arm is autonomous, what does that mean? Is there someone who programs it and pushes a button and it goes through its paces, or does it use some kind of AI to basically figure out its own tasks?
Yes. So it totally depends on the requirement of technical demonstration environment or customer missions. But basically, autonomous control, we call it is 99% autonomous control to 100% fully autonomous control. So, for example, the first internal demonstration we have conducted 3 years ago inside the International Space Station. And And as that demonstration, we have launched 1 meter size autonomous robotic arm and capable of assembling solar panels from smaller separate parts autonomously. And that was 99% autonomous control and 1% the kind of a human decision making on ground. So our autonomous software can recognize the environment through the stereo camera mounted on the edge of the robotic arm and recognize environment, including fiduciary markers, and calculate each position and conduct motion planning and then do actual operation. So it's a kind of a loop, autonomous control loop. And but at an important timing, we try to make a kind of a decision-making timing by human operators on ground. So it's basically 99% autonomous control, but only 1% not operation, but a decision-making process by human operators on ground. Or if we cannot get such kind of a like good communication environment between our spacecraft and the Earth, so we have to automate everything. So in which case, 100% autonomous control.
So what part does machine learning play in what it is that you're doing? Does the machine learn from its environment, and is it able to make changes in what it's doing based on what it learns?
Yes, our autonomous control software also include kind of like deep learning technology or machine learning technology, but basically, we also feel like people expect too much about deep learning or like machine learning technology. It's of course like we recognize that is a advanced technology, but not stable. Or so sometimes legacy like historical way much better performance. So we use for example, we use machine learning to recognize the condition of like the situation of interface. For example, if we try to conduct like push switches like on and off using our robotic arm, then our machine learning software can recognize that condition of switches on or off. So that kind of like judgment and recognition of the condition, we can use machine learning. And also we use deep learning technology to recognize as a object recognition to detect the like object and recognize that object is the like rock on the moon. So that kind of our object recognition purposes, we use deep learning.
What are some of the other ISAM processes your company is working to address?
We've been developing a space robot capable of conducting, assembling solar panels or communication antennas, and we also have conducted various ground demonstration in the Mojave Desert and like assembling a tall tower for communication antennas and solar panels, and also like at our internal demonstration as our first technical demonstration in space, our 1 meter size autonomous robotic arm have succeeded in assembling solar panels from smaller separate parts autonomously. So ISAM concept, ISAM technology is a really important technology, and we aim to realize that ISAM concept technology, such as assembling solar panels, communication antennas, even habitation modules, and ISRU plants. And we've been conducting both ground demonstration and in-space demonstration.
When we think about, traveling to the moon and eventually to Mars, it would seem to me that a lot of things are going to have to be done by machines like yours before the people ever actually show up. Is that kind of where you're looking at as far as your niche in all of this, that we've got to get there, build the infrastructure that needs to be built and get it all ready for the humans to come and live there?
Yes, we aim to help our like robotic workforce to build that kind of infrastructure in advance. For human like immigrants to Moon and Mars, and So like space environment is very harsh environment and very like dangerous environment. And actually there are lots of boring operation in space. And so we welcomed a lot of astronauts to our office, and we have heard like what kind of operation the human astronauts actually like conduct in the International Space Station. But to be honest, 80% of that operation sounds really boring. So daily chores, the cleaning, and high educated, super like talented astronaut had to conduct boring daily chores. And of course, it's important, but we can replace that kind of daily chores operation or dangerous operation with robotics technologies. So especially on the moon and Mars, we can provide and send our like robotic workforce to build infrastructure and to be prepared for the human astronauts and immigrants in advance.
I'm talking with GITAI Robotics CEO Sho Nakanose on the Terra podcast. Take a moment right now to click subscribe to be sure you don't miss any of our podcasts, or if you're watching on YouTube, any of the videos from Terra, the Journal of Space Commerce. Sho, as a company, what are some of the most significant challenges that GITAI Robotics has faced, and how have you overcome those?
Yeah, it's a difficult question. We've been facing a lot of difficulties, such as so basically, I'm a solo founder, so and having like had a limited budget and having like tiny prototype, but like I had to hire like talented engineers and like generating sales figures and raising funds from venture capitals, and so in the space industry, there are like lots of chicken and eggs problem. Like in order to generate sales figures and obtain contract from customers, we need to invest like huge resources in developing actual products. But in order to do that, we need to raise funds from venture capitals. But in order to raise funding from venture capitals, we need to have a track record. So it's a chicken and eggs problem. So, but fortunately, I'm a serial entrepreneur. So I have established my first company before starting the GITAI company, and I sold my business to a big organization. So spending that money, I had started to develop prototype of GITAI robots 7 years ago. And based on that, my prototype, I could succeeded in raising 1.5 million US dollars as a like seed round funding. And spending that money, I hired talented engineers and developing more like sophisticated, high performance space robotics prototype, and showing that we obtained contract from customers and like including JAXA. So yeah, solving chicken and eggs problem was most difficult problem. And when I established space robotics company 7 years ago, a lot of people said like establishing space robotics company was most stupid idea I've ever heard. Not all. I would not say all, but most people didn't believe I had no track record in the space industry, had no connection in the space industry, had a limited budget, could like establish space robotics company and launch something to space. But at least we have launched 2 in-house spacecraft, space robot to space. So yeah.
So then what are some of, in your opinion, the most significant trends and challenges that are facing the space industry today? And how is GITAI Robotics helping to address those?
I think like from our outsider perspective, like space industry is a very unique and strange industry. And so of course I know the like price of the space like products, like for example other industries, robotics capacity and price are totally different from that of the space industry. for example, the existing robotic arm in the space industry costs 1.2 billion US dollars and huge, like very long lead time. And so when I heard that price first time, I thought it was company valuation, but single robotic arm costs 1.2 billion US dollars. It's insane. So, but now I understand the, how to say, the reason all of the spacecraft, including robotic arms, like, how to say, are really expensive and long lead time is that most of the space companies follow a waterfall development method, relying on suppliers. And it's one of the most reliable development method, but it also leads to long lead time and expensive cost. So we follow agile development method based on the in-house production, minimizing lead time and cost dramatically, enhancing the performance rapidly. So we believe like that kind of agile development based on the in-house production, including all of the necessary components such as motor module unit, motor driver, all of the avionics, so electrical circuit, and mechanical engineering and effector, and of course, software development, including autonomous software development in-house. That makes GITAI standard and competitive. So we can offer more affordable and safe means of labor in space. So that kind of like expensive price, long lead time is a huge problem in this industry. And we aim to solve that problem in the agile development method based on the in-house production. So it's a vertical integration and minimizing cost, lead time dramatically, and providing safe, affordable means of labor in space.
I can't help but think that you're probably comparing that to the Canadarm, which would have been developed by a government, for lack of a better way of saying it. Yours obviously is a private company. What are some of those differences? How are you able to develop something in a less expensive way? And how do you differ from something like Canadarm, which has been around for a long, long time?
Mm-hmm. Yes. I think one of the advantages as a startup, so commercial company, would be, so we can adopt new, like advanced development way, such as agile development method based on the in-house production. And that is a new development method. And we can adopt that as a commercial company. But like government need to follow a waterfall development method. So like allocating a huge budget and human resources in that project. So that is one of the advantages, I believe. And also, in terms of the performance of robotic arm itself as a product, our robotic arm is more like autonomous, with autonomous, fully autonomous control software using the advanced technology from other industries. And so it's not space-oriented technology, but other industries, especially on ground oriented technology, we are bringing that advanced technology from other industries to space industry, so that our like inchworm types of robotic arm can walk around vertically and horizontally, even it's a 1G environment. So that is a huge difference, I believe. So of course, like Canadian arm has a similar function, so like inchworm type robotic function, but only GITAI's robotic arm can walk around vertically and horizontally through dedicated interfaces, like even it's a 1G environment. So it means we can provide robotic workforce to not only like low Earth orbit, which is a microgravity environment, but also to lunar surface and Martian surface, which is a like gravity environment, and and build infrastructure such as solar panels, communication antennas, habitation modules, and ISL plant. So we aim to provide that workforce to lunar surface and Martian surface.
Your company was recently selected as part of the DARPA 10 project. So what is your niche in DARPA 10? What is it that you're bringing to the table that made DARPA sit up and take notice?
Yes, thank you very much. We will be in charge of providing robotic workforce to build infrastructures on the moon. So that's exactly what we aim to realize and what we want to do. So we are the we cannot disclose the detail of that mission, but
Sure.
we are only robotics company to provide robotic workforce to the moon to build infrastructures such as solar panels, communication antennas, and other DARPA's mission. So yeah, that is the exactly ISAM technology, and we've been realizing step by step, and so yeah, we believe that ISAM technology on the moon and Mars would be the critical key technology to build infrastructures and minimizing the cost of working in space by 100 times.
How important is that to a company like yours, to a startup company, to be noticed by an organization like DARPA as one of the 10 companies they want to work with out of all the hundreds of space companies that are forming out there?
Yeah, it's a huge step for us, especially like we believe there are two meanings. One is as a startup, so like with limited resources, limited like number of employees compared to like big organizations such as Northrop Grumman and Boeing also being selected as companies of the DARPA Lunar team. But so it's a kind of a proof of our capability. So like DARPA selected like GITAI. So it's a huge proof for us to show our actual capability and as a startup. And also we have started in Japan. We already have completed entire relocation from Japan to the US. And like now our company's headquarters located in the US, California, and I got a green card. So now our companies are US headquartered company owned by US person, but so that we can meet the DARPA's eligibility. So it's easy to understand, yeah, GITAI now meeting the eligibility of the DARPA.
Outside of that, who are your target customers and how do you plan to reach them?
So we have three segments. So NASA, DoD, and commercial space companies. And so we have two business domains, and so like on-orbit satellite servicing and lunar infrastructure construction business domain. And each business domain has each target segment. And so we already have customer missions. Most of them we cannot disclose, but each business domains, we already have customers, both government, commercial space companies, and so NASA, DoD-related organizations, and commercial space companies in the US, they are our customers and potential customers.
Sho, what are some of the most important qualities you look for in potential employees, and how do you foster a culture of innovation at GITAI?
Yes, good question. Thank you so much. And so we are actively hiring in the US, and we sometimes see the significant kind of a mismatch between people from the space industry and people who are looking what GITAI looking for, and who GITAI looking for, and especially if a person has a startup experience, such as like a startup founding a startup by themselves in other industries, and or joining the early stage startup and facing a lot of difficulties and solving that difficulties step by step by themselves. That kind of experience, we really admit and with high evaluation. So that kind of like startup person, the more suitable person for us. So we don't think, for example, like 20 years, 30 years space experience will be like critical experience for GITAI. I don't think so. So, but our startup experience, would be more important experience for us.
When you talk to young people who might be interested in starting a space robotics company or getting involved in the industry, what kind of advice do you give them?
I don't recommend establishing a space robotics company. I totally don't recommend. It's a nightmare. And so you have to face a lot of difficulties, like no one can understand, and even like developing hardware so difficult. Entering the space market so difficult, and like raising funds from venture capitals, such a disaster market situation, it's crazy. So I cannot recommend someone like to establish a company, but yeah, the number of entrepreneur would be really important, like KPI to create ecosystem and new industry. So like, of course, welcome and hope to like entrepreneur to establish the kind of a company, but joining emerging company is more smart option, I believe.
It's almost like the old saying about the best way to wind up with a small fortune in whatever businesses is to start out with a large one. Start out with a large fortune, you'll wind up with a small one.
Yes.
At least it seems that way in almost every industry. But Sho, we're just about out of time, and I really appreciate you taking time to talk with me today. But I want to close, and we ask this of all of our guests, to look out, if you might, the next 10 to 15 years in space commerce and GITAI's role in that, and tell me what you see.
Yeah, I really have a like optimistic future in the space industry. Like humanity has been expanding horizontally, and now is the time for us to expand vertically. And while SpaceX reducing the cost of transportation to space by 100 times, we at GITAI are taking on the challenge of reducing labor cost by 100 times, providing a safe and affordable means of labor in space. So that is GITAI, and if you are interested in joining GITAI, please let me know.
Well, thank you very much, Sho. I really appreciate your time, and it's been a very interesting conversation.
Thank you very much.
Sho Nakanose is the CEO of GITAI Robotics. And that's going to do it for this edition of the Terra podcast. You can subscribe to the audio version of the podcast on Spotify, Apple Podcasts, Google Podcasts, Audible, and many other popular podcasting platforms. Be sure to click subscribe so you don't miss any of our podcasts or any of our other videos. You can also get daily updates on space commerce by subscribing to the Journal of Space Commerce on Substack at www.xterrajsc.com. And one thing more, be sure to connect with us on LinkedIn and follow us on X at xterrajsc. Until next time, I'm Tom Patton. Thanks for joining us.
I wanna go faster, faster. Hands in the air, we're gonna crash. Searching for the answers like Galileo through his looking glass. Thirst for reason. Our dreamer's eyes we gaze into a sense of purpose known by few. Like finding water on the moon.